So we're started off with two values for the left light bulb. Now this table's not written right. There should be two bulbs. There's not one bulb and one resistor. So let me fix that first. Call this the left bulb, and the other one can be the right bulb. All right, so anyways, for the left-hand bulb, we're given two values there. We're given 6 volts, so that goes under the voltage column. And we're given 15 ohms, so that goes under the resistance column. And that will allow me to calculate the current, actually. But I'll also write down the other value we're given in the diagram, which is 0.3 amps for the right bulb. That would go under the current column. Okay, so I will calculate the left bulb's current first. So to do that, I use Ohm's law. And that is going to be 6 divided by 15. You can put that in the calculator and end up with 0.4 amps. Okay, so what else can I do? I can use the current law. So I know my amps, I know the speed of the charges through each pathway, basically. I just calculated through this pathway, the speed of the charges is 0.4. And through the other pathway, the charges are 0.3. So what will happen is they're going to combine together right at this junction point. Right at that junction point, they're going to add together. So 0.4 amps plus 0.3 amps will end up making 0.7 amps. So that is the current law. And that 0.7 amps is going to go and travel towards the battery. So I'm going to write 0.7 amps for the battery. Okay. In terms of voltage, I can think about voltage now. So the voltage law states that in each loop in the circuit, the voltage gains has to equal the voltage drops. So what I'm going to do is focus on the inner loop first. So highlighting in green here, this is what I refer to as the inner loop. So from the battery to the first bulb and then back to the battery. From the battery to the first bulb and back to the battery. That's called a loop. And in that loop, I see one light bulb using 6 volts. Where did it get that 6 volts from? It got it from the battery. Therefore, the battery has to provide 6 volts. And that's simply the voltage law. Similarly, I'll use the yellow highlighting now. If we applied the voltage law again, but to the outer loop, so start at the battery, go all the way to the second bulb, and then come right back to the battery. So this is the yellow loop here. That's considered a loop. And what's inside of that loop? Just one light bulb. One light bulb. It's going to receive voltage from the battery. And it's going to be 6 volts again. So that is the voltage law applied to a parallel circuit. It works differently than in series. Okay, now I will be able to find the resistance of the last resistance there that's blank. So using Ohm's law, my current is 0.3, my voltage is 6, and I have to find the resistance. So basically 6 divided by something has to equal to 0.3. 6 divided by something has to equal to 0.3. And if you can't figure out what that is with mental math, you can go with a calculator by doing 6 divided by 0.3. That's algebra skills, and that will equal to 20 ohms. And that completes the solving of this parallel circuit.